We're going to learn something new from this video, which is identifying the y-intercept. But before we do that, let's go ahead and review the slope. Remember that slope is always when we have a rate of change. So the rate of change, whenever we are talking about how the numbers are changing in a table, how the numbers are changing in a graph. We're going to go ahead and use the table that's shown in the middle of the page, and we're going to plot those points on this grid. So my first coordinate point is like a -8, -5. So I start at 0, 0. I'm going to go over to -8. I'm going to go down to -5. Then I have -4, -2, 0, 1, and then 8, 7. So these points can be connected to show that they are in a straight line. I can extend them out to show that the lines go on forever. So at the very top of the page, this is just a reminder, the slope of a graph is done by using the rise over the run. Remember that the rise is going up or down on a graph. The run is going left and right on a graph. So if I go up or if I go to the right, that means that that is a positive movement, like I would be adding. If I go to the left or down on a graph, that means I'm subtracting or showing a negative movement. So looking at these 2 points, if I choose 2 points for my graph, if I go ahead and choose these 2, I can say that I have 1, 2, 3. I'm moving up 3 lines. And since my grid is going by ones, I can say that I went up 3 numbers. Then I can go to the right, 1, 2, 3, 4 numbers, which means that I'm also going to have a positive 4. So for my slope of my graph, I'm going to have rise over run. I went up 3 numbers, so my rise is a positive 3. My run is a positive 4 since I went to the right. So 3/4 is as simplified as it gets. So that is my final answer. On the slope of a table, so the slope of a graph, we can use the phrase rise over run because that reminds us on the movement of the graph. But you don't really move up or down on a graph or on a table. So we talk about how we have the change in y over the change in x. So change of y, if you ever see the symbol of a triangle and then y, the triangle means that you're changing, and then a triangle with the x means that you're changing with the x values as well. So what it means with this change, so in a table, we're changing from a -5 and we're changing to go to a -2. So the math that has to be done to do that has to be adding 3. From -2 to +1, I'm adding 3. And from 1 to 7, I'm adding 6. Same thing on the x. From -8 to a -4, I'm changing by adding 4. From -4 to 0, I'm adding 4. And from 0 to 8, I'm adding 8. So as I'm looking at my changes, I can see that not all my numbers are the same. I have a 3, and a 6, and then I have a 4, and an 8. So while this movement is changing by adding 3, at the same time, I'm adding 4 over here. So my change in y is 3. My change in x at the same time is a 4. Same thing for this next set. I have a change in y of 3 and a change of x of 4. And then my last one is a change of 6 and then a change of 8. So even these fractions don't look all the same, but if I reduce this last fraction down, I know that I could take both these numbers divided by 2 and still get 3/4 as my answer. So it makes sense that both of these have the same slope because I literally just used these points to plot the graph. But what the whole idea of this is practicing the slope, creating the table to the graph. but then also identifying some things that we see in the table in the graph as well. So on the graph, put a star over the point where the line crosses the y-axis. So on the graph, we have an x-axis that is a horizontal line. We have our y-axis, which is our vertical line. And we have this diagonal that cuts through it all. We're looking for the point that crosses over the y-axis, which is going to be at the point 0, 1. So the point that when this line crosses this y-axis, it is called the y-intercept. The y-intercept is one of the most important points because that's also known as the start of the graph. This coordinate point on this graph is 0, 1. The y-intercept is always when x equals 0. So we see that in the graph where it physically crosses that y-axis, but we can also see it in a table when my x value is 0, my x value is shown in here. So the coordinate point can also be found in the table. So if you turn your paper over, the next page we're going to be practicing finding the slope and finding the y-intercept. So the goal that we're trying to get to do is I can identify the slope and the y-intercept in tables and graphs. So we're going to go ahead and find the slope of this table. So we're going to have the slope of tables are when we take the change in y over the change in x. So from 7 to 8, it is changing by adding 1. From -2 to 0, it is adding 2. So one of my fractions is 1 over 2. Same thing on the next one. I'm figuring out how I'm going from my 8 to my 12. I'm adding 4. From my 0 to 8, I'm adding 8. So there's another change or another ratio. So I have my 4 over my 8. And then the last one, I can show that I have 12 to 14, I'm adding 2. And 8 to 12, I'm adding 4. So that is another ratio of 2 over 4. So all of these ratios look very similar. We can prove it by simplifying them down. And when we simplify them, they will all equal 1/2. So I know that my slope is always, or for this table, is going to be 1/2. All right, for the y-intercept of the table, remember y-intercept is always when my x value is 0, because my coordinate point is always 0, comma, a number wherever it crosses the y-axis. So looking at my table, I'm looking at my x column, I'm figuring out where 0 is, and I'm circling it or highlighting it. And I only actually need the y value. So I already know that the x is 0. I need to know what this number is in my y column. So my y-intercept is at 8, which really just means at 0, 8 on the y-axis. At that point, that's where the line would cross the graph. All right, let's try the next one. The next one is a graph. I have 2 points on my graph that I can look at. Remember that I'm finding the slope by doing rise over run. So I can see that my axes go by 1. So whenever I move a line, I can just count by ones. So I have 1, 2, 3, 4, 5, 6. So I went up 6 numbers, and I'm going to the right 2 numbers. So since I went up, that's a positive 6. Since I went to the right, that would be a positive 2. And I have to simplify this down to 3 over 1 or just the number 3. Either one of those would work. My next step is to find my y-intercept. Y-intercept of a graph is where the line crosses the y-axis. So I want just a single number. So I know that this is my y-intercept because this is where it crosses my y-axis. And at that actual point is 0, -3. So I only want this y number. So my y-intercept is -3. And my last problem, again, the same thing as my first one. I'm going to find my slope of my table. Slope of my table is always when I have the change in y over the change in x. To go from a -18 to a -6, I'm adding 12. And from a -8 to a 0, I'm adding 8. For my next, well, that will be a ratio of 12/8. For my next ratio, I'm looking at -6 to a -3. I'm adding 3 on that one. And then from 0 to 2, I'm adding 2. So that would be a 3/2. And then my last ratio to find my changes, I'm looking at -3 to a +6. And that's adding 9. While 2 to 8 is adding 6. So I would have 9/6. So again, I have 3 different fractions that all look different, but when I simplify them down, all of them can be equal to 3/2. Because I could take 12 divided by 4 and get 3. 8 divided by 4 we get 2. 3/2 I can't simplify down anymore. And then this fraction, I can divide both these numbers by 3 to get my 3/2. And then my last step, my y-intercept of a table is always when my x equals 0. So on my y-axis, the coordinate point would be 0, something. So I'm looking for my coordinate point. If I graphed it, this point would be where my y-intercept would land. And again, I just want that y value, so I know my y-intercept is at -6.